An iron wrecking ball has a radius of 18 centimeters, and the density of iron is given in non-standard units as 7.8 grams per centimeter cubed. So in part A, you just want to convert the grams per centimeter cubed into the standard units, kilograms per meter cubed. So this is just a simple conversion. We start with converting grams into kilograms. We know that 1 kilogram is 1,000 grams, so the grams part canceled out. And then we can convert the centimeters into meters, and you know that 1 meter is 100 centimeters, but because the centimeters is cubed, we'll have to take this whole conversion factor and cube that, which will allow the centimeters cubed to cancel out with the centimeters cubed in there, and all that is going to be equal to a total of 7,800 kilograms per meter cubed. One of the easiest things you can remember, instead of going through the whole conversion again, is if you're ever given the density in units of grams per centimeter cubed, you can just multiply it by 1,000, and that will convert it into kilograms per meter cubed. And then for part A, the specific gravity is equal to the density of the wrecking ball divided by the density of water. So that's going to be the number we just found out, the 7,800 kilogram per meters cubed divided by the density of water, which is 1,000 kilograms per meters cubed, and you end up with an answer of 7.8. And there are no units on that, since it's a ratio of densities. And you can see that that answer is exactly equal to the numerical part of what it was first given in grams per centimeter cubed. So now for part B, what's the weight of the wrecking ball? So the weight, or the gravitational force, is mass times the acceleration of gravity. Mass is equal to density times volume, so we have rho vg, and so that's the density. The volume in this case, because it's a sphere, is going to be 4/3 pi r cubed. So the total formula is rho times 4/3 pi r cubed for the volume times g. So that is equal to the density in standard units, which is 7,800, times 4/3 pi times the radius, which was given as 18 centimeters. You have to convert that into meters, so 0.18 cubed, times the acceleration of gravity, which is 9.8. So the weight, or gravitational force, ends up equaling to 1,867 newtons.